Lesson 7.1 is on scientific notation versus standard form. Your learning targets are to express numbers in scientific notation, convert numbers in scientific notation to standard form, and use scientific notation to write estimates of quantities. Vocabulary. There's scientific notation. It's a way to write a number as a product of a number, a, and 10 to the n, where a is between 1 and 10, and n is an integer. This means that when we write it, it's always a product, so we're multiplying. And we're multiplying a number times 10, or times the power of 10. So that's what this 10 to the n is. It's a power of 10. And then we're writing our number as a. It has to be an integer. Standard form is a way to write a number using a digit for each place. So standard form is just your regular way to write out a number. Why do we use scientific notation? It's helpful when numbers are very, very large or very, very small. For instance, the diameter of the sun is about 1,392,000,000 kilometers. So we could use scientific notation to make that number more manageable. Before we do scientific notation, you need to understand your powers of 10. So 1 is 10 to the 0 power, because we learned that anything raised to the 0 power is 1. But if I go up in my powers of 10, I'm just multiplying by 10. So 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1,000, and 10 to the fourth power is 10,000. If you notice, the exponent matches the number of zeros. If we go smaller, 10 to the negative 1 is 0.1, 10 to the negative 2 is 0.01, 10 to the negative 3 is 0.001, and 10 to the negative 4 is 0.0001. In example A, we're going to convert 25 billion from standard form to scientific notation. So I need to figure out where to move my decimal. And that answer is always to make our number between 0 and 10. So our number, remember, has to be greater than 0, but less than 10. So I'm going to make it 2.5. In order to make it 2.5, I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces to the left. When I do this, I can write it as 2.5 times 10 to the 10th power. The exponent comes from how many times I moved my decimal. Example B, I'm going to convert 435,000 from standard form to scientific notation. Again, my number needs to be in between 0 and 10, which is going to make it 4.35 in this case. And I'm going to move the decimal 1, 2, 3, 4, 5 times. So I'm moving the decimal 5 spaces to the left to make it 4.35 times 10 to the 5th. Now we're going to go the other way. we are going to turn a number that's already in scientific notation to standard form. So I'm going to convert 6 times 10 to the 4th power from scientific notation to standard form. So what this means is I'm going to move the decimal back. So instead of moving our decimal to the left, we're going to move it to the right. And I'm going to have to move it 4 spaces to the right because the exponent is 4. This also means 10 to the 4th power, if you recall, is a 1 and 4 zeros. So that's 10,000. So it's like I'm going to take 6 times 10,000. So in standard form, this is 60,000. But just to show you how the decimal moves, if I have 6.0 and I need to move it 4 spaces to the right, that's 1, 2, 3, 4. I put in zeros, and that's another way to show that this is going to be 60,000 in standard form. We're going to convert 7.5 times 10 to the 6th from scientific notation to standard form. So I need to move the decimal 6 spaces to the right. So 7.5, 6 spaces to the right. There's 1, 2, 3, 4, 5, 6. Fill in the gaps with zeros. And that is going to become 7,500,000. Again, I could think about the powers of 10, so that is a 1 with 6 zeros attached. So it took 7.5 times a million to get 7,500,000. You can use scientific notation to write estimates of large numbers that have many non-zero digits. Estimates consist of a single digit times a power of 10. According to the U.S. Census, the population of California in the year 2010 was 37,253,956. Write an estimate of the population using scientific notation. Our book says that our estimates consist of a single digit times a power of 10. So that means I am going to round to whatever the highest place value is, which in this case is 10 million. So I'm really looking at 30.7, and I'm going to round it up to 4. So I'm rounding the value to 40 million. So using scientific notation, that will be 4 times 10 to the 7th.